Hello students, in this video we will continue with prisms. Again, more problems we will do. In the last video, I did a numerical with a prism A, B, C, where a ray of light was incident normally at the surface and it was going without deviation, and we studied that it is grazing over the surface. As this degree, it was 60 degree, and we found that the angle of emergence this to be 90 degree. So angle of emergence is equal to 90 degree, angle of the prism is equal to 60 degree, right? I did a small mistake, I got caught in this point actually. I was going on assuming that the angle of incidence is here. So I was substituting a wrong value, right? So angle I plus angle E is equal to angle A plus angle D. Fine, we have to calculate angle D. Now angle I is here, and what is the angle of incidence? Which is equal to 0. So I should have taken this as 0, but I was stuck in this point, so I was going on taking 60 degree and the answer was coming wrong. Yes, so 0 plus angle of emergence is 90 degree, which is equal to angle of the prism is 60 degree plus angle of deviation, or angle of deviation is equal to 90 minus 60, that is 30 degree, which is angle of deviation. Dear students, I want to tell you something. That day when I was stuck while taking the video, I wondered, where did I make a mistake? Yes, I then stopped the video, I moved away, and then I was thinking of the same, where did I make the mistake? Yes, then suddenly when I came back and saw this picture, then I remembered, oh my God, angle of incidence is here at this face AB. But my mind was focusing only on this. Dear student, though I teach for 30 years, I am teaching physics. I got stuck. For you are also new to this learning of physics, the subject, the concepts. In examination, when you are looking at a particular question and you are solving it, and if you are stuck, do not go on prodding on the same thing. Yes, sometime what will happen, you may get stuck like that. It can be so many reasons are there, because you are in stress, you are working the whole night, maybe so many reasons are there. But if you get in that point and go on trying to do, you will be wasting a lot of time. So I suggest you leave that problem, that place, give some space, and then do some other problem, What will happen actually? The concept which you did a mistake or you didn't understand, right? It will be in your subconscious mind. And suddenly, as you are doing something, this back of the mind that will be working. And suddenly, when you are doing some other problem, maybe in electricity or magnetism or in electrons and photons, anything, suddenly in a spark, like a flash, it will come to you. This is really called lateral thinking, right? This is referred to as lateral thinking. Don't get stuck in the same thing. Then time will not be enough for you to complete the paper. Yeah, so skip it at that particular time, again come back and you will find a solution, right? That's how I did it. That's what I'm sharing it with you. Today we will do other numericals based on prism. Two more numericals which I would like to do. Okay. Yes. Yes, let me take the numericals and let me explain it to you. Yes, I am reading the problem. A ray PQ incident on a refracting face AB is refracted in the prism ABC as shown in the figure. This is the prism. and A, B, C. And a ray of light PQ is incident on it. And let us drop a normal here. And it is refracting inside like this. And it is emerging out like this, right? And this is R and S. Here they have given a condition from the other phase, refracting phase AC, okay, from AC, such that AQ is equal to AR. This is the condition is given. AQ is equal to AR. Okay. What is AQ? This is AQ and this is AR, right? If these both are equidistant, that means this is going to be the base, right? The refracting or the refracting ray, the refracted ray and the base are parallel to each other. First condition, these two are parallel to each other. What does that mean? When will it happen? That time angle of incidence will be equal to angle of emergence. And for a 60-degree prism, you will find that the angle of deviation which you are taking will be equal to angle of minimum deviation. Yes, at the angle of minimum deviation, the refracted ray inside the prism will be parallel to the base. That is the first condition. Second, what will happen? When will it happen? That time angle of incidence will be equal to angle of emergence. And that angle is called angle of minimum deviation, which you did it in a graph and found that this is what is happening. Angle I is equal to angle E. Okay. So this is the angle of minimum deviation. With this in our idea, and also they have given the material of the prism has a refractive index of √3. So let me keep the problem aside. Let me try to solve the problem. So I have refractive index. Refractive index N is equal to sine A plus D by 2 divided by sine A by 2. Yes, that is equal to sine A is 60 degree plus D we don't know by 2. Put it in a bracket divided by sine 60 divided by 2. You can put it in a bracket which is equal to refractive index. That is, refractive index is √3, right? √3 is equal to sine 60 plus D by 2 divided by sine 60 by 2 is sine 30. Sine 30 is 1 by 2, right? So this half you bring it here, multiply by 1 by 2. So I can write it as √3 by 2 is equal to sine 60 plus D by 2. So what is √3 by 2 in terms of sine? That is nothing but sine 60 degree, which is equal to sine of 60 plus D divided by 2. So we can say that sine we need not worry. So this is degree 60 degree. So this 60, this 2 comes this side. So 60 into 2 is 120 is equal to 60 plus D. Okay, or we can say D is equal to 120 minus 60, which is 60 degree. So the angle of minimum deviation turns out to be 60 degree in this numerical. I hope you understand. This is one problem which is using this concept, and another which you always use is sine I plus sine E is equal to, angle I plus angle E is equal to angle A plus angle D. These are the two formulas which we often use. Now I would like to do one more problem based on total internal reflection. Okay, so let me see what is that problem. Yes, this also in the previous year papers it has been asked. Yes. Let me read the problem. Yeah. First, let me draw the diagram, then you will understand better. This is a 45-degree prism, 45 degree, 45 degree, 90 degree. Okay, right angled prism. And a ray is coming and striking, another ray is coming and striking, third ray is coming. This is 1, this is 2, and this is 3. And this is a triangle A, B, and C. Let me read the problem. 3 rays 1, 2, 3 of different colors fall normally on one of the sides of a isosceles right angled prism as shown. The refractive index of the prism for 3 rays. 3 rays are having different refractive index because colors are different, so refractive index also will be different. Okay, and 1.52. So these are the 3 different values are given. Okay, find which of these rays get internally reflected and which get only refracted. Trace their path and justify your answer with the calculations. Okay, so this is the problem. We know this is a right angled prism. Let us take for example the middle ray. Let me take it straight like this. Let us suppose the second ray is totally internally reflecting. So what will be the condition that time? You will find that if I drop a normal at the point of incident, right, and this is going to be 90 degree and this is 45 degree and this is 45 degree. You know, for glass, you find that usually we take the refractive index of glass, we can say mu is equal to 1.5. And for glass, the critical angle is 42 degree. Okay, and we also know that mu is equal to 1 upon sine IC. We know this also. Keeping this formula, let us say for this is a supposition, right? And this time the angle is 45 degree and the reflecting angle also will be 45 degree. So naturally it is totally internally reflecting. So 45 degree, that is the angle of incidence, is greater than critical angle, correct? That is 45 degree is greater than 42 degree, fine. Or I can say sine of 45 degree is greater than sine of 42 degree. So this is also true. Okay, so what is sine 45? 1 upon root 2, right? Now sine 42 degree, I have taken critical angle. 1 upon sine IC, that is nothing but here greater than 1 upon mu. Can I say? Watch carefully. Sine IC, this 42 is nothing but critical angle. Okay, if you have problem for 42 is nothing but critical angle. This is 42 is nothing but critical angle. If I sine IC, if I say that is 1 upon mu, sine IC comes here. For example, I'll write it here. Sine IC is equal to 1 upon mu. Okay, I put it 1 upon mu. Okay, or we can say 1 is greater than root 2 divided by mu. Okay, or we can say mu is greater than root 2. That is mu is greater than 1.414. That means the refractive index should be greater than 1.414. In that case, total internal reflection will take place. If mu is less than that value, what will happen? The ray will get refracted. We already learnt in total internal reflection, right? A ray at an angle is coming, it will get refracted, moves away from the normal. Another ray, critical angle, grazes over the surface, right? It's greater than the critical angle, total internal reflection. Already we learnt the concept. So we know that refractive index should be greater than, using these conditions, we have tried and we said that refractive index is greater than this value. Okay. So now look here at this figure. The first ray is 1.39. 1.39 is less than 1.414. Will it totally internally reflect? No. So you'll find that the ray will go normally and it will come out like this from the other face AC, right? And next is 1.47. Okay, 1.47 is greater than 1.414. So naturally it will go total internal reflection. And next is 1.52, another color. That color also will have total internal reflection. So this is what the whole system is about. I hope you understand the concept. Yeah, these are the basic concepts based on that numericals are asked. Okay, so now I have completed more or less some selected problems from ray optics, that is belonging to prism. In the next video, I would like to come with the lens maker's formula as well as lens equation, and if you keep a lens, how things will happen, how the mu value is going to change. All this we will study in the next video. If you have any doubts, please write it in the comment section. I'll be able to answer. Thank you so much.